Hello. Uh, this video I'm going to explain you Aodv, ad hoc on-demand distance vector routing protocol. So this routing protocol falls under reactive routing protocol, which means whenever any node wants to send some data to another node, at that time they will start searching for the path. So before, if they don't want to send any data, they won't go for any route searching. So at the time of when it's needed, at that time they um, start looking for, is there any, what is the feasible path. So Aodv is the reactive routing protocol. Aodv, we can say this is a extension of DSR, dynamic source routing. So before going for Aodv, just have a look on DSR disadvantage. So in case of dynamic source routing, whenever a node finds out a route to the destination, the path will be included in the data itself. The data packet carries the entire route. So for example, say if our network is not large, so path will be small. But if our network size will grow, so in that case the bytes required to store path in data packet will also increase. So most of the time in this case, network bandwidth will be not utilized fully, because most of the time most of the bandwidth is used to send path across the nodes. So this was the first disadvantage. The second one, in DSR, for one destination there are multiple route possible. One node can cache multiple route for the same destination. So in Aodv, uh, Aodv reactive routing protocol, the route discovery mechanism is similar as we are having in dynamic source routing. So this in order to discover a route, first it will send a route request packet. When the destination receive that packet, they will reply by sending route reply packet. We will see this example in later slide. Now in Aodv maintain all the route in the form of table, where in DSR tables are not used, but here we are using table. Aodv routing protocol store all their path in form of table. Now when any entry is made in table, one timer also associated with that tables. That timer will that timer will specify at what time that entry should be removed from the from the table. And the third one is the destination sequence number. Destination sequence number, it can be considered like a timestamp. So at what time we have received this path information from the destination. So in case of, if the information is old, the information is not fresh, the information is stale, in that case the destination sequence number can be used to check whether that coming information is fresh or not. So inclusion of the sequence number also avoid routing loop, account to infinity problem. So let's take an example. We are having four nodes A, C, D, E. Our objective, A wants to send data to E. So initially node A is not having any information that where is that node E exists in the network. So A will start a route discovery mechanism. So they will they will broadcast the route request packet. So in route request packet, all entries are same as we are having in DSR, but there are some changes. So first one, every node maintain two counter. One is sequence number, so the sequence number will work as a timestamp, and second one is the broadcast ID. Whenever any node send a route request packet, that packet carries a unique ID. So that broadcast ID every node maintain. Whenever they send route request packet, they increase this ID. So next time when they will send route request packet, that will be having another ID. And this is the packet format for route request uh, in Aodv. So first entry is the source address, second one is the source sequence number. So when source will generate this packet, at that time they will include their sequence timer information, their sequence timer current value. And this is the broadcast ID. This is, we can consider it's a unique ID for route request packet. And then this is the destination address, destination sequence numbers. If sender is not having any idea about destination, so in that case this entry will be empty. And the last one is the hop count, how many hop it required to send the data from sender to receiver. So when destination receive route request, it will check the destination address and it will find out that this route discovery process is for its own. So in that case destination will reply by using route reply packet. So the format is source address, destination sequence number. So now when destination will send this packet, they include their timestamp, hop count, and this is the lifetime. This will specify for how long this entry, this path can be used. Intermediate node. So intermediate node, whenever they hear duplicate packet, they will discard it. Now in case if a sender is requesting for a route, they will broadcasting the route request packet. In case if intermediate node having any updated information, so instead of broadcasting route request packet, they will send a reply to the sender. So now let's continue our example. So A wants to send some data to E, so A has to start route discovery process. So under this process, A needs to transmit route request packet. So that packet we are considering here. So first one, source address, source sequence number, this is the destination sequence, this is the destination address, destination sequence number, this is the hop count, and this third unit is the broadcast ID. So we are assuming all these value from the initially, these are value this node is having initially. This hop count 0, this hop count actually signify the distance from the sender. So initially we are at node A, so distance between A to A is 0. So now A will broadcast this packet. So these are the meaning of these entries. So A will broadcast this packet. A is having only one neighbor, so this packet will be sent to C. Now C is not having any information about node E, so C will broadcast this packet again. Now before broadcasting this packet, C will update this hop count, because this hop count is the distance between current node and the sender. So now the current node is C and the distance between A and C is 1. So now C will update this packet. So every node maintain this information in the table. So these table we are considering only some few column here: destination, next hop, sequence number, hop count, and lifetime. So when C will receive this packet, C would know this packet is actually coming from A, and this packet came on this interface. Okay, this is connected, they're using this interface, it is connected to A, so it would know this packet is coming from A. So it will create an entry in the routing table. What is the entry? If any packet coming to C for destination A, C should transmit that packet in this direction. So it will create this entry in the routing table. So this is also known as we are keeping a backtrack for the senders. So this red line, this red arrow is showing actually C is keeping this information that A is reachable using this path. Now C increase the hop count and broadcast this packet again. D will check that the destination is E, so D also broadcast this packet, and before that D also make a entry. D will make, if this packet is coming from A from this side, so it would know in order to reach to destination A we have to go to C, and from here, from the hop count, it will get the hop count information. So this will be the current situation. Now D will send this packet to E. Now E will check this route request packet is actually for him. So now E will prepare a route reply packet, and before that E will also create a entry in the routing table. So this red arrow, they are actually keeping track for sender A how to reach A. So E has prepared a route reply packet, sender, receiver, destination sequence number, hop count. So again hop count is the distance from sender. So currently we are on E, so distance from E to E is 0. E will send this value to D. So now D would know this packet is coming from sender E from this side. So D would know in order to reach E I have to go to here. So it will create a entry in the routing table, and this entry will say in order to reach E forward the packet to E. Hop count is 1, and this is the sequence number. This is the timestamp at what time destination E has generated route reply packet. Now D will increase the hop count value and send this to C. C also make an entry that C will see this packet is coming from E and this packet is coming from D, so it would know in order to reach E we have to go to D. So it will create an entry, in order to reach E we have to forward our packet to D. It will take 2 hop count and sequence number is 120, and finally this packet will be sent to A. A create this entry. So now every node has updated their routing table and they are all having the information for node E. So now whenever A will send its data, and the data is not carrying the path information, data is not carrying any route, because every node having their own table. So whenever they receive any data packet, they consult their routing table. On the basis of that routing table, they forward their that received data packet to other nodes. Okay, thank you.